Hi, my name is Sir Henry, and I'm here to discuss to you about real number system. But what is a real number system? A real number system is a set of numbers that are used in mathematical problems. But for simplicity, I'm going to discuss these real numbers starting from the simplest going to the most complex. So without further ado, let's get started. The first number that I'm going to define is the number 0. 0 is a number that represents the absence of the value. Without 0, we cannot determine the difference between 4 to 40 to 400 to 4000 and so on and so forth. So 0 simply gives the absence of a certain place value. After 0, we have what we call the natural numbers. Natural numbers are also called positive numbers or counting numbers simply because they are used to designate the numbers that we need to count or we need to identify, okay, the quantity. Alright, after the natural 0, when we put them together, we can now have what is known as the whole number. In other words, whole numbers are numbers from 0 to other numbers starting from 1 to infinity. So 0, 1, 2, 3, 4, and so on and so forth. Then we have the negative numbers. Okay, negative numbers are numbers that we don't use for counting. Let's say negative 1, negative 2, negative 3, negative 4, and so on and so forth. These are numbers that tells the value which is less than 0. Okay, when you put together the whole number and the negative number, we shall now have what is known as your integers. Okay, so these numbers starting from 0 to natural numbers, to whole numbers, and negative numbers, when we put them together, we will see that these numbers are present in what is we call the number line. So say this is our number line. Okay, this is your 0, and all the numbers going to the right are positive numbers, also known as your natural numbers. So let's say 1, 2, 3, 4. The arrowhead here simply denotes that the numbers goes infinitely. On the other side, we have the negative numbers, negative 1, negative 2, negative 3, negative 4, and so on and so forth. As you can see, both ends of this number line have arrowhead. So as you can see, these numbers in the number line are what we call the integers. But the question is, what about the numbers that are in between the integers? So across the integer chart, set of numbers, we have what is known as the non-integers. Okay, across the integers, we have what we know as non-integers rational numbers. And what are these? These are numbers that are in between these integers, and most of the time they are expressed in a fraction. Okay, example of which we have 7 over 12, maybe 1 over 2, could be a mixed fraction or mixed number, 4 and 2 over 3. These are examples of non-integer rational numbers. Okay, so what's the difference? The big difference between these integers and the non-integers is very simple. For integers, this can be expressed also as fraction, except the fact that the denominators will always be equal to 1. Example, we mean negative 4 as negative 4 over 1, and positive 7 as 7 over 1. See, A whole number or an integer can be expressed as fraction, but the denominators will always be equal to 1. Okay, so putting this together, we will now have what is known as rational numbers are simply the combination of integers and non-integers. But how are we going to determine if a number is rational? Very simple. It should follow the decimal value, like repeating or terminating. What exactly do we mean by decimals that are repeating? Example, we have fractions, decimals like 0.3333 and number 3 repeats infinitely. Okay? Another example is 0.7272 and so many. Another one is 0.444. Most of the time we put a bar above the numbers telling that this number repeats continuously. The other one is terminating. What are terminating numbers or decimals? Terminating decimals like 1.50. Okay, as you can see, there are no other numbers after the number 0. So meaning the decimal value terminates right here. Another example is 3.75. And as you can see again, there is no number after 5. So the decimal terminates on zeros and 5. So if the value of the fraction or a number either repeats or terminates, then we say that that number is a rational number. Okay, and finally, across the rational number, we have your irrational number. Sorry. Okay. Irrational numbers are usually in the form of radicals. Example of which, the square root of 2. These rational numbers are in the form of radical or the constant like pi. The value of square root of 2 is actually 1.41421365, and there are still a lot of decimal values after the number 5. But we don't write it anymore. So you see, this value is far different from the repeating decimal and the terminating decimals. Another example is 3.1416 or 3.14155926, which is known as the pi. Okay? For simple computation, we only use 3.14. But the actual value of your pi is an infinite decimal values. Okay? So this time, when you put together the rational numbers and irrational numbers, what we will have is the real numbers. So there you have it. This is what we call the real number system. I hope you learned something from this video, and I'm looking forward to see you again in my next video. Thank you, and God bless you all.